Good evening. If you will all find your seats, I think we'll get started. Want to thank you all for coming, and also welcome to the people who are watching on streaming video. The Moose Family Speaker Series on Water Resources is sponsored by the Freshwater Society and the U of M's College of Biological Sciences. This is our 11th lecture in our speaker series that began 3 years ago. Thanks to Bob Eldy, the Dean of the College of Biological Sciences and a former board member of the Freshwater Society. Bob, who normally moderates the questions from the audience after the talk, can't be here with us tonight, so Pat Sweeney from the Freshwater Society will be taking his place. The special thanks also to the Moose family for the Malcolm Moose Freshwater Fund. The endowment honors Malcolm Moose, the president of the University of Minnesota from 1967 to 1974, and helps support this lecture series. We're very proud of this lecture series. We've all learned about the sustainability of groundwater use, pollution from farm fields and city streets that degrades all of our waters, saving the environment by putting a dollar value on its benefits, corporate efforts to promote sustainability, and climate change and the future of water resources. If you've benefited from these lectures, as I have, and you appreciate the kind of work that Freshwater is doing on important issues like groundwater sustainability, I urge you to become a member of our organization. We also have a recently published report on Minnesota groundwater that's available in the lobby. We're privileged this evening to have our guest, Dr. Don Rosenberry, as a research scientist from the U.S. Geological Survey. Says Don is a native Minnesotan who grew up near Walker, scuba diving in the many area lakes and in the summer and snowmobiling on them in the winter. Says he may have even met Malcolm Moose while mowing one of the lawns along the north side of 10 Mile Lake, during the summer. Don earned bachelor's and master's degrees at Bemidji State and the University of Minnesota. He received his doctorate from the University of Colorado. He now lives in Colorado, but he coordinates a USGS long-term research project in Shingabee Lake between Walker and Park Rapids. And in fact, he does a lot of research around Minnesota. In fact, I think he spends as much time here as he does in Colorado. And he took part in the USGS-led research on a decade-long decline in White Bear Lake. His particular piece of that work was to quantify the exchange between groundwater and the lake along the nearshore margins of White Bear Lake. Don's going to speak tonight on the flows of water from the lakes and streams into groundwater aquifers, and the flows that go in the other direction too, from groundwater to surface water. The title of his talk is Not Just for Scientists Anymore, Why the Public Should Care About the Connection Between Groundwater and Lakes, Streams, and Wetlands. After Don's talk, a panel of 3 Minnesota experts on water will join him in taking your questions. As we're passing out file cards now for you to write questions on for the panel to answer later. If you have friends who cannot be with us this evening, tell them to go to our website and find a link to the video of the lecture. As we're privileged to host Don Rosenberry tonight, and we're honored to have all of you with us. So if you would, please help me welcome Dr. Don Rosenberry.
Well, thank you all for that warm welcome. And before I start, I need to thank you for your patience regarding my on again and then off again and then on again attendance here tonight. The sequestration kind of threw a wrench in the plans, and we are evolving in our interpretation of the sequestration and what we can do in regard to those rules. But they've changed slightly, and I'm able to travel now for some things, and I'm able to be here tonight, so I'm really glad to have your presence here and that you were patient enough to live through this with us. I've got this first slide up because someone told me once that you just can't see groundwater. People don't understand groundwater, you can't see it. It's not always true. Sometimes you can see groundwater. So my talk tonight is about the relevance, the societal relevance of what we in USGS do and in particular, what we're doing related to groundwater surface water exchange, why the research that we do that sometimes seems an esoteric pursuit affects you. And I'm going to give some examples tonight of how it affects you and many of the other people in Minnesota and across the U.S. So the USGS mission statement points out that we are all about societal relevance. You know, it says that we do science, we provide scientific information to describe and understand the earth, to minimize loss of life. I mean, it doesn't get much more relevant than that. So there are definitely relevant reasons for conducting this type of research. And the type of research that I do in particular, the people that I work with, looking at groundwater, surface water exchange, and the ways to understand it and manage it, developing new tools to quantify that exchange. When you read the statement here, it seems maybe perhaps a bit obtuse and maybe not all that interesting to most people, certainly to scientists, but you have to ask the question, how is this relevant to you? How is it relevant to the taxpayer that's funding this type of research? How is it relative to the Freshwater Society, to everybody here? So I'm curious how it's relevant to everybody here. Who here is here tonight because of White Bear Lake, because of issues related to White Bear Lake? Raise your hand. Okay. I thought there might be a few more. All right, who here is here because you live on a lake or a wetland, or you recreate on a lake or a wetland? Raise your hand. Okay. Either one of these reports would be of interest to you. If after tonight you'd like more information, either one of these is a really good source of information. Who here is here tonight because you happen to drink water? Okay, there we go. Well, for 3/4 of you at least, you get that water from the ground. Groundwater in Minnesota supplies at least 3/4 of the drinking water for the state. And it's a large number for most of the other states across the country. And these are a couple of reports that have recently come out that talk about groundwater and the sustainability of groundwater. The one on the left pertains to groundwater in Minnesota, put out by the Freshwater Society recently. I highly recommend you pick up a copy if you don't have one. And the one on the right pertains to the entire U.S. But before I get going, I told Pat I would give a little tutorial on just what groundwater is, because he said a lot of people have a misconception of what groundwater is. So let's take a packet of material, sand or gravel or silt or clay, some porous medium that's in the ground, and if all of the spaces in that block of material that are not grains of sand or silt or clay, if those voids in between those grains are full of water, that's groundwater. And this porous medium that you see here is the groundwater medium for virtually all of Minnesota. Now there are a few other types of groundwater flow. Here we see interconnected solution channels where some of the rock has dissolved. That usually occurs in limestone. This is maybe the closest thing that we have to the idea that there are these massive underground rivers transporting water, or big underground lakes. Some people think that that occurs. This is the closest that it comes, but it's nothing like that, really. This kind of a terrain occurs in southeastern Minnesota, Rochester in particular, but there is some of this type of material here in the Twin Cities Basin. This cartoon shows fractured rock. So here we have bedrock, essentially, solid rock. You can't get water to flow through solid rock, right? But if that rock is cracked, if it has fractures, and if those fractures are interconnected, then you can have flow through that rock. And so if you drill a well down into that solid granitic or whatever type of rock that is, you can actually pull groundwater out of that material. But in Minnesota, the vast majority of groundwater occurs in this type of material. So where is groundwater in Minnesota? Everywhere. It's virtually everywhere spread across the lake, across the state. Now, you can't get it everywhere. In some places it occurs in materials that won't release the water. Water can't flow through it very readily. But it's down there. It's all over the state. And the lakes basically are a surface expression of this vast groundwater system. Wherever the groundwater intersects a low spot in the terrain, a lake or a wetland will occur. That's a very simplified view, but that's essentially the way it is here in Minnesota. So what happens if Minnesota also is in a unique setting climatically? It's a place where precipitation, snow and rain, approximately balance evaporation. But it's a delicate balance. So what happens if precipitation drops? Well, the water table drops and the lake levels drop. And what happens if it drops even more? Well, that's when it gets interesting. That's when the people really take notice of the connection between groundwater and surface water. That's when the media get interested. That's when Perry Jones starts showing up in the newspapers and on television. That's when people really pay attention to the kind of work that we do at the groundwater surface water interface. And I'm going to start out tonight by talking a little bit about this situation with White Bear Lake. Well, the reason we're so interested in White Bear Lake is this line right here: record low water level for the entire period of record going back to the 1920s. And you remember the drought period in the 1920s? Well, you don't remember it, but you certainly read about it. Well, now conditions are even worse. And certainly when a situation like this comes along, people take notice. But it's kind of tough keeping up with these record conditions. So I made this slide. Actually, I got it from Perry Jones. It was made a few years ago. A couple, actually, maybe only one. And this was the record low in 2011. Well, now the record low is even lower. In 2013, in January, a new record low occurred, another a half a foot or so lower than the previous record, and I don't like the trend, and that's why people are concerned. Well, this is White Bear Lake. For those who don't know, it's in the northeastern Twin City metro area. It's a pretty nice lake. It's kind of an intermediate-sized lake. It's about almost 3 miles across, 2,400 acres, surrounded by towns and development and some golf courses. So it's a very nice lake. I've done some work on it. I was impressed. But if you go to Google and you type White Bear Lake, these are the kinds of images that pop up. Conditions are not normal there. It's a challenge to launch your boat on White Bear Lake. You can't go swimming at the public beach on White Bear Lake. For the last 5 years, this beach has been closed. The beach used to be right here. This used to be covered by water. It was a nice sandy, gently sloping beach. But now the shoreline has retreated to a place where the bed slopes more steeply, where it's kind of dangerous, where it's weedy. The water gets deep fast, so they have closed this beach. If you wanted to hop in the boat and motor across the lake to go out to dinner at a restaurant in the town of White Bear Lake, it's pretty tough to do that when you can't get your boat to the marina in town. So things are extreme at White Bear Lake. There's good reason that there's so much concern about this situation. But if I lived in White Bear Lake, this would be my biggest concern. How long is my dock going to get before this is over? I mean, some of these docks are unbelievably long, and you don't realize how long they are until you have to carry a gas can from the end of the dock all the way to the shore and beyond. So what's going on? We've done some work here. The USGS and others, DNR, have looked at the situation at White Bear Lake. We've looked at the hydrology. We looked at the balance of water supply to the lake, the loss of water from the lake. And I think this slide is particularly telling. So you saw the hydrograph, the history of the water level changes in White Bear Lake. This blue line is the same thing that you saw earlier. But in this slide, I've also drawn something called the cumulative departure from normal precipitation. That's the black line here. And basically, this is based on a 30-year average of rainfall and snowfall in the White Bear Lake area. So, if we had normal precipitation from 1970 until 2012, this black line would be perfectly horizontal. It would just parallel that red line, which is the ordinary high water line. So when this line slopes downward, that's a drier than normal period. When this line slopes upward, it's a wetter than normal period. And you can see this line goes up and down, which tells you one thing, and that most of you probably know this, is it's almost never normal. Normal is just an average, but we rarely have an average condition occur. So this line is moving up and down, but it's trending generally downward, and this prolonged downward slope of the line here during the 1980s was a really substantial drought that extended all across Minnesota and the Dakotas, and it was maybe the most severe drought since the 20s or the 30s. And during that time, you can see the response of the level of White Bear Lake. It started out above the ordinary high water line, and it plummeted. It dropped 5 feet in just a few years. And what's interesting here is that when precipitation began to increase, and when it became greater than normal, lake stage continued to drop. There was a lag, there was a delay. That's pretty common, actually, in hydrologic systems. There's a response, a delay in the response. And the lake stage came back up along with increasing precipitation until about 2000 or so, when, curiously, the lake stage began to drop even though the departure from normal line was continuing to increase. And then finally, things became drier than normal. The precipitation became less than normal, so the slope again was downward, and the lake responded much more substantially to a smaller dry period, a less severe drought than the one that we had in the 80s and early 90s. So clearly there was something different here. Something different was going on to pull the water level in the lake down, much more so than just its response to precipitation. Well, at White Bear Lake, we have precipitation and evaporation, and that's about it. There really aren't any surface water sources to White Bear Lake. There's a small creek that flows some of the time. There's no outlet to White Bear Lake, no surface water outlet. So really the only other thing that we might explain this difference in lake stage response could be a groundwater surface water exchange. So we have a few surprisingly simple tools that we commonly use to quantify exchange between groundwater and surface water. These were developed by Minnesotans. This is developed by David Lee back in the early 70s. He was a student here at Minnesota, and then he went on to North Dakota. This is a half-barrel seepage meter. It's the cutoff end of a 55-gallon storage drum. So basically it isolates a quarter square meter of lake bed so that any water that flows across the sediment water interface beneath this meter will enter the meter and flow into a bag that's in this little shelter, so that we can measure the gain and volume in that bag, and that's an indication of the groundwater exchange at this location. It's pretty common for groundwater to discharge to surface water, mainly because the surface water is generally occurring in the lowest parts of the landscape. But it's not always that way. A lot of times we have surface water flowing to groundwater. If that's the case, all we have to do is put a known volume of water in the bag and measure the loss of water. So this device can measure the flow in either direction. It's about as simple and cheap as science gets. It's a really simple concept. There are several sources of error that we can deal with, but it's only a measurement at this one point. And so you can imagine that this is a rather labor-intensive endeavor. We have to make these measurements at multiple places all around the lake to get a whole lake picture. Another characteristic of groundwater surface water exchange that's really fortuitous is that it happens to be focused in the nearshore margins in most settings. Not always, but commonly it is, which makes it easier to conduct this kind of work. We can work in shallow water. We don't have to have scuba gear, for example, to do this. This is something that we call a hydraulic potentiometer, a mouthful. Joe Magner is really familiar with this device. I saw Joe, he's here tonight. Basically, it's a portable well. We can stick a well screen in the bed of the lake beneath the bed, some distance beneath the bed, and we can measure the water level at that well screen. If the water level inside the well, based on the head at the well screen, is higher than the lake level, that means there's the potential for groundwater to flow into the lake. If it's lower, there's the potential for lake water to leak and flow into the groundwater system. So these two devices are really inexpensive, they're simple, but they're robust, and combined, they can give us a lot of information about what's going on. So we used these methods, and we made measurements all around the perimeter of White Bear Lake. And we found groundwater discharge around most of the lake. And not just groundwater discharge, in some places it was discharging above the lake. This is discharge at Matamidi Beach, and it's some distance above the shoreline. The lake was over here somewhere. There's a place where groundwater is coming into the lake. In fact, when we look at the lake-wide data that we collected, all of the red and yellow dots indicate places where groundwater was coming into the lake. The only place where the lake was losing water was on this northwest side where it was headed off to Bald Eagle, which is substantially lower than White Bear. So we've got this dry period, we've got a lake level that's declining. We thought maybe it was losing water to the groundwater system, and instead we find that groundwater is discharging to the lake around almost its entire perimeter. So something else was going on. So I mentioned some of these USGS reports that are really useful. They're written for the lay reader. This is one of them. And in this report is this diagram. And this diagram shows a typical setting where groundwater is exchanging with surface water. So here we have a water table in an aquifer. And the water level here is higher than, in this case, a stream. And so water is flowing from the higher head into the surface water body. And then this diagram shows another setting where everything is the same except that we've put in a well, and this well is pumping water. And when the well is pumping water, now instead of this groundwater flowing to the stream, it flows to the well. And in this situation, the water level in the well is low enough, it's drawn down the head in the aquifer enough, that now water is flowing not to the stream, but from the stream. So what if we had a similar setting, but instead of a stream, we have White Bear Lake? And what if instead of this confining bed, we have additional aquifers beneath the superficial aquifer? And what if that well was deeper and it was screened in the aquifer that's substantially below the superficial aquifer? In that kind of a setting, we could, if the well is pumping water, have flow from White Bear Lake to the well in the deeper portions of the lake at the same time that flow is coming into the lake in the shallow nearshore margins. And this is what we think is happening at White Bear Lake. Now we've got several lines of evidence to support this work, and the one that I think is most telling, most compelling, is the water chemistry, the water isotopes in particular. Isotopes are part of the water molecule itself, and the isotopic signature of the surface water is different from the isotopic signature of the groundwater. And by measuring the isotopic signature of the water that's coming out of the well that's being pumped, we can calculate, with a real simple calculation, the mix, the relative source of water to that well. So Perry and his colleagues sampled many of the wells surrounding White Bear Lake, and they found that a lot of these wells had a surface water component. Some of the water being supplied to the well that's in the ground came from a surface water source. And for one of the wells, 3/4 of the water was surface water. So we think that there's a substantial amount of water coming from the deeper portions of the lake and flowing laterally to supply the well, while at the same time gradients indicate that groundwater is coming in around the edges. So we think this is what's going on. And we have the expert, I think, in the audience. Perry Jones said he would be here. Oh, he's here, yes. So if you have any questions beyond what I've talked about tonight, talk to Perry. He's the guy. and read the report. This just came out not long ago, and it tells a much more complete story than what I just gave you. So things are tough, things are a concern, and this is a concern in other parks, not just White Bear Lake. There are some other lakes that are experiencing similar situations, and it's bad. But it could be even worse. This is a lake in Michigan that I did some work at a few years ago, where it was just unbelievable. The lake basically abandoned these people. This guy is out on the lake bed walking around toward his lake home in the distance. I can't imagine building a dock that long. So this is Long Lake, or was Long Lake, near Kalamazoo in Michigan, and things had gotten pretty dire at this location. This is a dock that, there was no question they weren't going to extend that. The lake retreated really rapidly. And here's the swimming raft that no one's going to dive from anytime soon. And you just basically have to take a hike to get to the end of the dock. Well, these people were very concerned. Property values were plummeting. It was no longer a fun place to live. And so they pooled their resources and they installed a well. So they installed a well to pump water into the lake at about 2 to 3 million gallons per day. It cost a fair bit of money, but, well, what great is a lake home? What good is a lake home if there's no lake? So this is what 2 to 3 million gallons per day looks like. This is 2,500 gallons a minute coming from the pumping well, which is back in these trees here somewhere. And this flows down a narrow channel into the lake. And at that pumping rate, it's not too difficult to calculate the rate that the lake stage should rise. And they started the well, and they ran the well, and they ran the well, and the lake stage did rise, but not nearly as much as they had calculated. So they wondered, where's all the water going? Something else is going on here. So they asked USGS to take a look at this. So we used our commonly used tools. We made measurements all around the lake to look at the groundwater surface water exchange going on. So here's the lake. This is that place where the shoreline retreated over a quarter mile. This is what's left of the lake. The pumping well was right here. And we made measurements all around this lake, and we found really small rates of exchange. There was nothing extraordinary about the groundwater surface water exchange except for one place. There was one place where we found some pretty large rates of groundwater surface water exchange, and it was right here. It was in this area right near the pumping well where there was a large loss of lake water flowing into the groundwater system. So they basically had created a circulation cell, pumping the groundwater out, and the lake was leaking right back into the groundwater system. It was a bit of a sad story. Luckily, the dry period ended, wetter conditions came along, and the lake stage recovered. Well, it can go both ways, and it often does. Remember Duluth and Moose Lake and lots of other places in Minnesota last summer. This was a lake also in Minnesota in the late 1990s, at the same time that we were doing work at that other lake that was disappearing. The wet water had moved to Minnesota, I guess, away from Michigan. Imagine how hard it would be to sell this home in this kind of a condition. If you owned this home, this would be a huge concern of yours. And it was a really interesting place to do research. This is Lake Beltane. It's in Minnesota, about halfway between Walker and Park Rapids, for those of you who know northern Minnesota. Beltane, silver beauty in French. But the Ojibwe had a different name for this lake. Translated, their name for the lake is Lake at the End of the River. They had it figured out. They understood the hydrology, the really unusual hydrology of Lake Beltane. Lakes normally aren't at the end of a river in Minnesota. The Great Salt Lake maybe, but not any lakes in Minnesota. So here we have 10 lakes that are all connected by Little Sand Creek that all drain into Lake Beltane. And there's a substantial flow into Lake Beltane, a cubic meter per second, about 35 cubic feet per second about, what did I say, 22 million gallons a day coming into Beltane, and there's no outlet. There is no surface water outlet from Lake Beltane. So where's all the water going? I was kind of embarrassed. I had been a hydrologist for quite a while. I grew up in Walker. I drove by Beltane countless times. I had no idea this was such an unusual setting and that this was going on. Nor did most of the people that live around that lake. I guess they just never thought that if you have an inlet, there should be an outlet too. But the reason we were working there was because the well drillers who were drilling wells, and they have to report information to the Minnesota Geological Survey when they do this, they noticed that the water temperature for the wells that they installed on the south side of Beltane, the water temperature was much warmer than they were used to seeing. They thought maybe there was some geothermal activity in this area. So they contacted the University of Minnesota. That request went to Calvin Alexander, who I think might be here tonight. And Calvin came to us. We were doing some work nearby at Shingabee, and we started looking into this. And it was a fascinating setting. So here's Beltane. We're looking to the east. There's Leech Lake, about 100 times larger. But Beltane's a sizable lake. It's 1,200 acres. And here you can see the water level of Beltane almost 50 feet higher than the water level of the Crow Wing chain of lakes just to the south, about half a mile to the south. So we've got a big gradient. We've got unbelievably clean, coarse sand in between these two lakes. And so what was happening was we had extremely fast seepage rates. At this time, when this was published, this was 200-some centimeters per day. That's a big, big number in the groundwater, surface water world. So we had big exchange, and essentially the outlet was groundwater. The groundwater, the sediment, the sand, was so permeable, it transported water so readily, and the gradient was so large that the 22 million gallons a day coming in was flowing out through the ground. So an amazing, unusual setting. Groundwater, surface water was a big part of the story, and nobody knew. What happened here? Until something changed. So Beltane, it's a really nice lake, like so many others in Minnesota. A great place to play. There were several resorts there, a lot of lake homes. Just a really pleasant lake. But then things changed. The precipitation became greater than normal. So when we were doing the study, this is the Beltane hydrograph now. This doesn't go back quite as far as White Bear Lake, but it still goes back into the 30s. And this is the ordinary high water line here. We did our study right during this period, and after we collected our data, the water level continued to rise until it got substantially higher than the high water line. And this is what you would see all around the lake. The shoreline moved into the yard up against the cabin. It took out the boathouse. Ice heaves, like you had on Mille Lacs, not quite that big, would take out the boathouse in the spring. I mean, these kinds of things were happening. The resorts had to shut down because either the road was flooded or the entire septic system was underwater. And so there were lots of problems. And then all of a sudden, they were very interested in our research, and we had county commissioners reading a journal called Water Resources Research to look at the work that we had done on White Bear Lake just by happenstance. And they were asking, what can we do? So they had some good ideas, several solutions to deal with this problem, one of which was kind of out there and one that I don't think anyone would think of, and it wouldn't be appropriate for any other setting, but that was to manipulate the lake bed to get the lake to leak faster into the ground. So groundwater, surface water exchange being discussed by county commissioners. Well, what happened eventually, before any decision was made about what to do, because these things take some years, the conditions returned to normal. Precipitation excess became less, back to normal basically. The lake stage came back down, and well, problem was solved. But this is what it looked like during the high water. And my concern, though, is I don't like the trend here. If you look at the Beltane record, the stage is gradually increasing. This was that really high wet period, but look at the long-term trend. I think that they're going to have to deal with this problem again in the not-too-distant future, and I hope they have one of those solutions in their back pocket. So wet periods, dry periods, they cause concern. The public is much better informed and made aware of groundwater, surface water exchange. But it's relevant to other issues, societal issues too, water supply being one of them. Water supply is becoming a concern here in Minnesota, but it's been a concern in other parts of the country for a long time. One of those being California. So this was some work we did in the northern San Francisco Bay Area related to the Sonoma County Water Agency that had several water supply wells that were removing water basically from the Russian River. It's pretty clever, really, what they do. This is a Ranney collector, a very large diameter well. This one was about 60 feet below the river. And at the base of the well, they put out these lateral screens. These are 8 inches in diameter. Some of these are several hundred feet long. And they go out in all directions, and they pump water. And you can imagine the volumes of water these wells can pump. So they were pumping almost 80 million gallons a day to supply the northern Bay Area with water. Each one of these could pump about 20 million gallons. So you might ask, why don't they just take it out of the river? Wouldn't that be a lot easier? They could, but then they would have to treat it to a much greater extent than they have to treat it if they're pulling it from the ground, because the flow path from the river to the collector well is basically a filtration system. As this surface water flows through the groundwater, that porous media that I showed you earlier, any pathogens, anything that's living is filtered out. So by the time it reaches the well, we don't have so many concerns about bacterial or biological processes. Well, the problem was the wells started to produce less water, and they wondered why. And they thought, I think the riverbed's getting clogged or something. So we went out with our meters, we made measurements, and this is the collector well, this is the river, flow is from right to left, and these are the numbers we were getting. The seepage measurements made closest to the well, directly over one of the collectors, was the smallest. And once you get farther away, we had some really big numbers. Remember earlier I said 200 was a huge number? That's for natural conditions. This is rather unnatural. But here's a big number, 650. That's massive. They're really fast seepage rates through the bed out here. But this part of the bed was clogged. That was the problem. That was the reason that the production of that well was declining over time. I did it again. So we came to some conclusions. This is an ongoing study, and so we're talking about what to do next. But part of the problem was that we had this clogging bed, and it wasn't uniform. But being able to map it, being able to determine where the clogging was occurring is a big step in improving the production. Meanwhile, the demand for water continues to increase. So the production is going down. So they solved the problem by installing another collector well. These things are really expensive. I don't know how many tens of millions they cost, but several. And they solved the problem by pulling more water from the river. And more water is better, right? They can supply that added demand, and problem solved. Well, 78 million gallons, that's about 120 cubic feet per second. The flow in the river at the time this photo was taken was about 300 cubic feet per second. That's 40% of the flow. They're cutting the flow almost in half. So it's great if you're drinking water in the northern Bay Area. You're getting water that doesn't have a lot of chlorine, and you're getting water that's there when you want it. But if you're out recreating on the river, and it's a very popular lake for recreating, as you can see, you get past this area where the collector wells are, and the flow in the river is greatly diminished. Now all of a sudden you're getting stuck on sandbars. It seems like a minor problem, but it's not just a problem for the canoers, it's a problem for the fish and the other organisms that rely on the flow. So it's a societal issue. And no matter which side of that issue you're on, groundwater surface water exchange is at the center. So here's another example of societal relevance. Another example, this one a water quality example, and I know we've got several of those here in Minnesota going on. This is some work that we did in Puget Sound, a place where there's a lot of water, like Minnesota here, where the weather is very similar to what it was like this week. So this is a really nice place. We worked on Lynch Cove, the far end of Hood Canal, this really large, long fjord feature. And I get to work in some really nice places. I'm so grateful for the places I've been, but this is one of the best. I mean, it's just, when the weather is nice, this is just a fantastic place. These are the Olympic Mountains in the distance. This is looking across Hood Canal. It's just a beautiful, nice place. Very popular. A lot of people love to live here. But there were some changes that were going on in Hood Canal that people were very concerned about. And they were related to these algal blooms that were becoming more and more frequent. And some of these were toxic, as is the case here. But the bigger problem was that the algae were proliferating, they were dying, they were consuming oxygen, and in response to that decreased oxygen in the water, fish were dying. So you had lots of fish floating up on the beach, and other organisms too. This was a highly productive ecosystem that was becoming a concern. So one of the first suspects is excess nutrients. And in this case, we were thinking of nitrogen. And so USGS was charged with finding out how much nitrogen was being supplied to the system from groundwater relative to other sources of nitrogen. So we went out there and we started making measurements. And it's a beautiful place, and a lot of people live here. And I have to ask, what is the minimum lot width in Minnesota? I think it used to be, maybe it's county dependent, but when I lived in Walker, I think it was 100 feet. Is that common? The minimum lot width? Depends on the city. Okay, well, it's 50 feet here. And I know we have setbacks. You can't have a residence any closer than some number of feet from the high water line, right? Well, I'm not sure that they have any setbacks here because they seem to love the water. You can't get too close to the water. And every one of these places is on a septic system. And we were trying to avoid the water. That this is the high tide line right here. We had all our equipment up to keep it out of the water. And we just happened to notice that this tree had grown around this tank that used to be a septic tank. So they're really close to the water. Some of these places are really old. It could be that some of these systems are failing. Now, we don't actually know that. We haven't looked into that yet. But what we did do was quantify the amount of nitrogen that was coming in from groundwater. Whether the nitrogen that we measured was contributed to by some of this leachate, we don't know. But what ended up in the sound was a greater amount than was coming in from all of the rivers coming into this part of Puget Sound. So a substantial contribution of nitrogen was coming from groundwater. So groundwater surface water exchange was a substantial part of this story that's continuing to evolve. So I'm almost done here because I know you have questions. But I've got an example. I had to have at least one. I mean, all of these examples are related to us, to people, but we're not the only ones that use these resources. And ecosystem health is a big issue that groundwater surface water exchange is strongly, closely linked with. So here's an example, one of many I could show, from southwest Montana. And I show it because it's another really pretty place. It's gorgeous. This is the Red Rock Lakes Wildlife Refuge. Has anybody been there? Southwestern Montana? Oh, one person, only one. It's a beautiful, oh, okay, a couple of people. 3, oh, all right, yeah. So you know it's a really nice part of the world. Well, the big issue here is trumpeter swans. This is the nation's largest rookery of trumpeter swans outside of Alaska. Alaska, it's always the exception. It's so big. But for the lower 48, this is the largest factory, so to speak, of trumpeter swans. Some might think that they're doing too well based on the increase in swan populations around here lately. But it used to be you didn't see them very much. And the number of nesting pairs at Red Rock Lakes is decreasing over time. It's a big concern. They want to better manage the resource, but they need to know how much water is coming into the system from groundwater. So we went out, used our normal methods, made measurements, and we got numbers like this, 0.8 of a centimeter per day. Not that big a number, but spread out over the entire system, it could be a substantial amount of groundwater discharging to this system. So we're making these measurements and we get numbers like 0.8 of a centimeter per day, but every once in a while we see a feature like this, a big depression in the lake bed, and if we put a seepage meter in one of those depressions, we get numbers like this, 2 orders of magnitude higher. So really, we need to be able to find these locations. We need to be able to make measurements and enough of these so that we can say when we see a hole, we've got a groundwater flow rate of such, and then identify all of the locations of these places, because otherwise we're greatly underestimating the groundwater discharge to the system. But how to do it? It's a labor-intensive effort. I mean, I guess you could canoe every square meter of the lake, at least in the shallow nearshore margins, and find these. But we thought that we might use temperature. So the temperature of the groundwater coming in through this area, if you take a temperature of the bed here, it's 6 degrees C. It's about 45 degrees. It's even colder than Minnesota's groundwater. It's cold. Whereas the bed around here was about 25 degrees C, so there's a nice temperature contrast here. So we thought, well, we can't fly over this area because it's a wilderness and aircraft are not allowed to fly in this wilderness. Landsat, satellite imagery, wasn't fine scale enough to really be able to see features like this. So we thought, let's take advantage of the USGS Air Force. This is a new capability that USGS has had for several years now. These are basically drones, these unmanned aircraft that you've been hearing about in the news that we were provided by Department of Defense. They very kindly basically gave these aircraft to us to use in the pursuit of science. And it was really fun. I used to be a pilot. I used to fly around Minnesota, so I was way into this. And it's pretty neat how it works. So here's Todd Preston. He's one of the people qualified to fly this system. He's from out of our Bozeman office, and he's about to launch one of these aircraft. And it's like launching a paper airplane. I mean, it's amazing. Here he is about to send it out. They've powered up the engine, and so you can't see the propeller because it's spinning. It's on full power, and he steps forward and gives it a big heave, and off it goes. It's that simple. Except for when it doesn't. Oh, he was so disappointed. You know, this is $100,000 or so worth of technology, and it's all in pieces on the road. And oh, it was a bad time. But no, it's not. These are designed to do this. This is how they land. I mentioned how simple it was to launch them. You basically crash land them at the end of the mission. You bring them in close so you don't have to walk very far to get, but then you crash it into the ground. It falls all apart. You put it back together and launch it again, this time maybe down from the road, so if it crashes, it lands in the grass, and off it goes. It's really neat technology. But the funnest, the most interesting thing I thought was the way you control it. So here's Todd. He's the mission controller. He's flying the aircraft. These 3 people are watching the image that's being produced by the aircraft. In this case, it's infrared, so it's sensitive to temperature. And they're seeing real-time the image, the infrared, as well as the regular visual spectrum. So it's got 2 cameras. And basically they're flying it along the lake. So I was in a canoe. I was out over one of those cold spots in the canoe, and they handed over control of the aircraft to me. I had one of these controllers, so I was watching myself fly the airplane. While watching myself fly the airplane, it was strange, but it was amazing. And so then I returned control to Todd, and he flew the rest of the mission, and we got information like this. So here was a pond next to the lake that we were mainly flying, and we would find features like this, a little dot. And that's what we were looking for. That's about the right scale. So in this image, white is cold and black is hot. And so we think that this is a spring coming into this pond that we really can't get to because the swans were nesting here. Though if there's a swan there, you don't go anywhere near it. But that's a place that we're going to investigate in the future if we pursue this. But for the lake shore, in a really short time, we could get information on the entire shoreline, and there's a lot of resolution. We could investigate these images and go back and find places that we want to look at in greater detail. So it's amazing new technology that can be put to work on an issue that's related to these trumpeter swans. So I'm about done now. This is where I'm headed in a couple of weeks, headed to the Delaware River, where the issue here is endangered species. And it's related to an interstate compact dictated by the Supreme Court, where the states of New York and Pennsylvania and New Jersey are sharing the water resources of the Delaware River. And they're sharing those resources with these endangered species that also depend on the water in the river. So it's an issue. The biologists think that the few remaining locations where this particular type of mussel can be found are also co-located with areas of prodigious groundwater discharge. So these are the kinds of things that we're pursuing at this particular site. And here's a picture of geophysicists using geophysical methods to map the geology beneath the bed of the river. So they're towing this device inside this tube. Here we've got a seepage meter in the foreground. Here's a piezometer in the bed. This actually is a mussel. We got pretty close to it. The biologists let us get pretty close to these mussels, but you don't want to step on them. There aren't that many left. It's kind of scary. I don't want to do it by accident. And I'm always ready for someone from the public, because this has happened numerous times, to come up to me and say, "What are you doing?" A lot of times they think we're dumping toxic waste because we have all these barrels here and pipes sticking out of the ground and dragging around floaty toys, and they see the truck with the government plates on it, and they wonder, what's going on? I'm ready for those kinds of questions. I've addressed those numerous times over the years, but there was something different about this setting. Questions that I had not ever had to deal with before. Almost uniformly, when people would come and ask us what we were up to, they were worried about this. They wanted to know if we were testing for chemicals coming into the river from hydrofracking. This was a big, big issue out there. And I end with this because even though this wasn't related to what we were doing, and we weren't sampling for any kind of exotic chemicals that might have been introduced, these people knew intuitively that exchange, flow between groundwater and surface water, was important to the environment and to their lifestyle in this part of the country. So these are just some of the examples of this relevance. So to sum up, who cares? Well, the things that live at the sediment-water interface, the mussels, the endangered mussels, other endangered species, birds. We talked about the trumpeter swans. I had several examples related to fish, but I thought you already know all about fish. And the people that study these systems and processes in animals, the scientists, certainly they care, but so do the property owners. Once you understand the connection between groundwater and surface water, if you happen to own a place on a lake or a wetland or a river or an estuary, you become very concerned about this exchange. Resource managers have been tuned into this for a long time now, and Minnesota's leading the way, I think, in managing our water resources, and in particular incorporating the new information related to groundwater surface water exchange. And of course, the public. But it's our job to inform the public, and we need to do more to produce products, not for each other, not so that we can communicate together as scientists, which we do routinely. We need to communicate this information in a way that's understandable by someone not trained in whatever specialty we happen to be trained in. So this was a publication that came out some years ago, and I think it's a great resource. It's got a lot of really nice information. If you want to know more about groundwater surface water exchange in general, I'd direct you to this. But we've got quite a few other reports too that USGS has been putting out. They're generally called circulars. We've got several publication series, but the circular series is directed to you, to the lay audience. And this is a great report that just came out from the Freshwater Society, and it's related to Minnesota in particular on groundwater sustainability, and it's very readable, and it's thorough, and it's compelling. I strongly recommend you pick up a copy if you don't have one. And before I end, before I take questions, as I've perhaps said several times, this is a labor-intensive endeavor. And without a lot of eager pairs of hands, this just could not be done. So these are some of the graduate students that have worked with me over the years, and I always have to thank them every chance I get. And I have to thank my colleagues from the various USGS offices across the country who have written the proposals, who have secured the funding, who are plugged into the local concerns that are related to groundwater surface water exchange that allow me to pursue and extend my research in these areas where it really matters. And in particular, in this case, Perry Jones, who's right there. And I have to thank the guy in the field, Perry Jones, up at Shingabee, between Walker and Park Rapids, where a lot of these methods were developed and tested and improved upon. So I think that's it. I'm ready for questions if you've got some.
Thanks very much, Don. That was great. I'm Pat Sweeney. I'm the Research and Communications Director for the Freshwater Society. I'm filling in for Dean Bob Elde tonight, and I will try to do this with a little bit of the grace and humor that he brings to these discussions, which are always really a high point of the lecture series. We're privileged tonight to have 3 Minnesota groundwater experts, most of whom have worked with Don. And they're going to join him in taking questions. I'm going to introduce each of them individually, and then after that I'm going to ask each of them to give a very short response to what Don has told you and to sort of add their experience and expertise, and particularly the Minnesota perspective to what he's told you. The first of these experts, in alphabetical order, Dr. Jeanette Leet from the Minnesota Department of Natural Resources. Dr. Leet has been involved in groundwater and groundwater surface water interchange applications and applied research since 1976. She's worked for the DNR since 1981 and currently is the Strategic Information Systems Manager for the Division of Ecological and Water Resources. She has a bachelor's degree in geology and environmental studies, a master's degree in forestry, and a doctorate in forest hydrology. Both her master's and doctorate are from the University of Minnesota. And then on Dr. Leet's right is Andrew Streitz from the Minnesota Pollution Control Agency. He's worked for 25 years as a hydrologist, first for the DNR and then for the PCA. He does groundwater modeling and provides statistical help for the agency. He's studied groundwater, surface water conflicts at Little Rock Creek, Bonanza Valley, and other watersheds throughout Minnesota as part of the PCA's intensive 10-year cycle of watershed investigations. He has a master's degree in geology from the U of M. And then on my immediate right, Dr. Robert Tipping has worked for the Minnesota Geological Survey, a unit of the university's School of Earth Sciences, since 1990. He works in public outreach and he conducts research on the geology and hydrogeology of fractured and karst terrain, groundwater surface water interaction, aquifer characterization, and groundwater chemistry. He earned a master's degree in geology and a doctorate in water resources science, both from the U of M. He's a member and current president of the Minnesota Groundwater Association, and I think most of these other people, and certainly Stu Grubb, who gave the introduction, are members of that organization. we're privileged to have all of them here. And Dr. Leet, can you begin with just your take on what we heard tonight?
I always...
Oh, and they asked me to ask everybody to speak close to the microphone.
I love Don's talks, and this one in particular, because this information is so accessible to anybody who drinks water. From the DNR perspective, I would like to invite people to check out our new web-based sources of information, things we're trying to improve. Information about lakes can be found on the Lake Finder. You can just try Googling different things, Cooperative Stream Gauging Network with the Pollution Control Agency. If it's raining cats and dogs, you can get online and see if the river isn't rising. You can see if the lake's rising, although our interactive real-time records for lake stage we don't have much in the way of that. Demand for water is increasing, and it's starting to matter in Minnesota. Conflicts that Andrew was mentioning are at the forefront of what DNR is trying to introduce into our new management approach. If you read the back part of the freshwater report, you will see that DNR doesn't come out the best. It's not that we don't have good laws. Julie Ekman is quoted as having said, we just don't have any teeth. In the last legislative session, the one that just ended, we were given a few new tools, one of which being that now people who want to drill a well have to communicate with the DNR, not just with the health department, about whether or not having a well in a particular location is a good idea. So bit by bit, we're gaining more tools, and we hope to educate more people so that people might change behavior and start treating the use of water the important way it ought to be treated, with respect.
Andrew, what was your take?
Well, I'm not sure everyone here understands exactly how state government divides up the responsibilities, so I wanted to start by saying that there are 4 agencies that work in water resources. My agency, the Pollution Control Agency, works on water quality issues. The Department of Natural Resources works on water supply, water quantity. Health Department works on drinking water issues, and the Department of Agriculture works on farm issues. My agency's specific interest in a problem like White Bear Lake, which Don laid out very nicely, is that declining water quantity can lead to changes in water quality. And because of this, the MPCA was an early sponsor of the White Bear Lake study, where we were able to bring clean water legacy funds available. And we're currently funding a study with the U.S. Geological Survey to provide Minnesota scientists with the first useful estimates of recharge of precipitation to aquifers across the state. The other thing that I drew from this talk is that, from my perspective, the White Bear Lake study has helped build a consensus that Minnesota is no longer a water-rich state, although this consensus has developed quite slowly. When I was hired by the DNR as a student worker 30 years ago, my first task was to find and clean old steel tapes that had been dumped from the last drought event in some sub-basement. Steel tapes were used in the old days to get water levels in wells. It was a good task to give to a student because it was necessary and it was grimy. Our team spent a whole year or two studying drought issues, and just as we were about to come up with some firm conclusions, the rain returned in vengeance, and we were tasked to work on flooding issues. And this happened, I discovered that this happened quite often. These cycles were at first surprising, but the real problem with this cycling is that we wouldn't have time to develop the science, and we didn't have time to catch up to the problem with policy. What I discovered in my 20 years working with the Department of Natural Resources was that usually rainfall was sufficient to meet our needs. And yet that pattern is now changing. This year we've had a wet spring, and if the rain comes in the right amounts, with the right frequency, then maybe farmers won't use so much irrigation for their crops. Maybe homeowners won't water their lawns as often. And maybe surface water features, lakes and streams will recover some. But the real danger is that a wet year might lead us to lose our focus on sustainability of groundwater. And if the USGS is correct in their assumptions and their conclusions that lakes with small watersheds in close communication with aquifers like Prairie du Chien Jordan, in the northeast metro mostly, they will not recover even in normal precipitation years. If those conclusions are correct, then I think we have a strong indicator that Minnesota is indeed not a water-rich state anymore. Anyway, those are my thoughts.
Dr. Tipping?
Well, I had a couple thoughts. One, kind of out of my realm, but something I've been thinking about a lot, and that's the value of groundwater or water resources. Most of the modeling that is done in trying to make decision making is based on trying to come up with a value for that water resource, and a lot of that is focused on surface water. And what Don's talk has highlighted is the close connection between surface water and groundwater. When those models are created, the groundwater part of that puzzle, that piece, is usually just a number, some sort of input or output. And what I'm particularly interested in and what we work on at the Geological Survey, Minnesota Geological Survey, is understanding better about how that system works. And from our perspective, it's all about understanding the actual aquifer or aquitard underground. How is that water moving? Is it moving quickly? Is it moving slowly? What's causing it to move in the directions that it goes? I love the picture that Don had when he started his talk of the boiling spring of the water slowly coming out of these sand boils. And again, it's difficult to run a groundwater field trip because there aren't many places where you can actually see what's going on. But in Minnesota, actually many of the aquifers that we're talking about, in particular with White Bear Lake, you can go and see these aquifers in outcrop in other places in the state. So we can actually get up and look at them and understand them. And so from my perspective, again, it's a way of understanding how the water is actually moving underground, and the insights that we can get into that can help with this idea of how you value groundwater by being able to predict where it's going to occur and how long it may be able to sustain at a certain level. So those are my thoughts.
So do we have some questions here?
We have some to begin.
Okay. And I encourage all of you to give us more questions. This is the best part sometimes. I think this is for you, Don. Do you think one reason for the increasing water level trend in Lake Beltane is due to ag field tiling and drainage? If not, what do you think is the cause?
That is a good question. That's a question I've been wondering about for some time. Why is Beltane continuing to rise? And I've thought about this a bit. I don't think it's related to agriculture. There's just not that much agriculture north of Beltane. There's a lot of it west of Beltane and south, but not much north where the water is coming from, where the water supply is up on the Itasca Moraine. I wonder if it could perhaps be due to the lake bed slowly becoming more clogged over time. There's a lot of development around Beltane, probably quite a few nutrient sources. I don't think nutrients are a problem because they're being lost with that flow to groundwater that then goes down to the Crow Wing chain. But there are continuing accumulations of organic material that are continuing to clog that bed on the South Shore. If that process has been going on for, well, as long as we've had as long as the glaciers have retreated, so thousands of years, if that process is increasing, perhaps due to something that we're doing, then that clogging rate increases, and then the lake level goes up because you can't lose as much water to the groundwater system. That's just one potential reason. It may also be related to development of the lakes upstream. Maybe for some reason there's more water coming into those lakes, which then flows down to Beltane, but I really don't know anything about that. Maybe there's someone here from the Park Rapids, Walker, Nevis area, Nevis in particular, that might know something more about changes in the landscape. I don't know. That's a great question.
Here's one maybe you want to take a shot at, Andrew. Knowing what you have learned over the years, what concerns you most about clean U.S. drinking water?
I have to address the whole country. That's Don's area. I'm not sure. I mean, we're all focused. The agencies all work together on groundwater issues, and the last question raised up the issue of water tiling, and that's a big concern. One problem with tiling that wasn't mentioned here is that it short circuits the water cycle, and water that normally would infiltrate into farmland is now being whisked off and put into rivers, and it's flowing down the Mississippi. So that's water that was kept on the land in Minnesota, and I think that that's a long-term problem that we haven't dealt with. We don't regulate tile use, and so we know very little about it, and so I think that's the biggest concern I have.
Okay. And here's one, I think, both for Dr. Leet and for Don. How much less groundwater pumping from surrounding deep wells would it take to stop the decreasing lake level trends at White Bear? Are you able to, in any way, make an estimate?
Wasn't that Perry's next line of investigation?
That's exactly what I was going to say. One of the things we weren't able to do with the earlier investigation was do any quantitative estimates related to groundwater flow, groundwater surface water modeling. And this next round of funding, I think, is the plan. I talked to Perry this afternoon. That will be done. And really, you know, a model can tell you pretty much anything you want it to. But if you've got a well-calibrated model based on real data, which we now have, then you can use the model as a really nice what-if tool. You know, what if we weren't pumping this water? What then would happen to the heads in the aquifer and the exchange with the lake? So I think the modeling effort that will come now will be a really useful exercise in answering those particular questions.
Okay. And here's one for Bob Tipping, and then I'll ask all of you to respond to it if you care to, or any of you who do. It's about what we don't know now, and the question is, what should we be measuring or quantifying to help us manage our water better for sustainability?
Well, this is a great question. The things about water and water systems is that they happen in real time, and even in cases of groundwater, which we typically think of as having long residence times, is that things can happen quickly and dynamically. And one of the things that has changed recently, or is evolving as we go here, is the ability to collect data and collect data in real time. So, for example, water levels in the metropolitan area, being able to measure the response on a seasonal basis of how those water levels change gives us clues that we didn't have before. It's like taking a movie instead of taking a picture. To see how things happen over the course of time when these things are actually changing is incredibly useful for understanding how these systems work. So that would be one aspect. The other thing, then, this came out in Don's talk too, in the rainy wells in California, where you put in a meter in a particular place and all of a sudden you get insights that you didn't have before. And that's certainly the case in the settings here in the White Bear Lake. We put in a new well, we get new information. That type of basic research about the container, again, is really important. The Buried Valley, we haven't really talked about that. That goes underneath White Bear Lake,
cuts down into the Prairie du Chien group. And a more recent well that was just drilled, exploratory well, to look at what was in that buried valley, shows that it's all sand and gravel. So it's essentially sand and gravel 150 feet down from the land surface to the Prairie du Chien group, which is the top of this aquifer that we've been talking about. That type of information becomes very, very useful when we start trying to put all the pieces together. So I guess the two things I would talk about is real-time monitoring and, well, I could go down a whole list of tools, but those are the ones that come to mind. Real-time monitoring, chemistry as a tracer, and continued research in how these aquifers actually work.
I would make a plea for turning our attention to quantification of the actual water use. In many places, water use is only estimated, and the tools we have for metering water are really quite good. In some cities, they could be real time, but for most of our water users, I'm not so sure that the data reported are as good as they could be. A person without a meter makes a good effort, but without a meter, you don't really know. And that's just so simple, and it should be, more attention should be paid to that.
Quickly, I think I'm excited by the expanding DNR observation well network. They're increasing their network from 800 wells to, the number I've heard is 7,000 wells. And 7,000 wells sounds like an awful lot until you think about how big the state is and how you could put a well in a certain location, and then you have to ask, well, how deep do I put it? Because there are any number of aquifers at that location. So, but with this new resource, I think that we're going to have a lot more information, and that's useful.
For the people who may not be aware of them, can you guys just say a little bit about the atlases that the Minnesota Geological Survey and the DNR do?
Sure. County atlases are a program that's been around for a number of years, and most of the counties here in the metropolitan area have been mapped. The basic idea is to try again to map the physical container for a given area. And a lot of these maps are groundwater driven, but that's not the only reason they're done. But the atlases, again, they're done on a county scale. They're based largely on well data, among other things. But it's a mapping of the bedrock that's beneath the surface, and also the unconsolidated material that's on top of the bedrock. And since probably the early 1990s, we have do these atlases in conjunction with the DNR. So there's a Part A and a Part B. And the Part A that I've been talking about, again, is the physical setting. And the Part B, if you want to address that.
Is Jan in the audience? Jan Faltasek at DNR is the supervisor of the County Geologic Atlas work group. The plates are developed after MGS puts the container out there. We model the travel of water and what it may contain into deeper layers. So we can then assess the sensitivity of a particular aquifer in a particular setting to that potential for contamination. One thing we have received funding for recently is to go and stitch all of these together, so that, again, you would eventually be able to go online and find the best information that we have after we get everything edge matched and ready to use in an interactive environment.
And much of this is ready right now. I mean, you can go on, do a Google search for geologic atlases, and you can take a look at many county plates, both the geology and the hydrogeology. They're very useful.
Here's one for Don, I think. For the other northeast Twin Cities lakes with low water levels, can the knowledge obtained from White Bear essentially be extrapolated to them, or does each lake have to be studied independently?
I would say yes and yes. The conditions, the processes going on at White Bear Lake probably are similar to conditions at many of the other lakes. I mean, certainly the balance between precipitation and evaporation, the change in that balance at White Bear is the same as that balance at the other area lakes. There may be special circumstances at some of these other lakes that are different from White Bear Lake, so you'd have to use some care in extrapolating the results that we obtain at White Bear Lake to these other lakes, some of which I think we can readily extend, and others maybe not. So that's why I say yes and yes. Kind of a wishy-washy answer, but that's unfortunately the way it usually is with science. Some of the information can be readily extended virtually everywhere, and other parts are pretty site-specific.
I want to remind all of you to stay close to your microphones. And then here's one for Dr. Lead, I think. Is there a good estimate of natural replenishment rates of Minnesota aquifers? And is there any ongoing research efforts to study potential artificial methods of aquifer replenishment?
Well, USGS and DNR did a study of, a generalized study of recharge to groundwater. We have a pilot or two on where you put the water back in. Trying to remember it's aquifer storage and recovery process, but that isn't really what's meant here. In the White Bear Lake discussions, people have talked about finding areas where you could encourage recharge, but we don't have anything organized that comes to mind.
Okay. I'm going to ask a question that I wrote down as you spoke, Don. You said you had a slide that said, "Time heals all wounds." And is there any reasonable expectation that White Bear is going to rebound without some significant intervention?
I've seen this several times in settings across the country where there's a concern about a trend, where conditions are becoming dire, where everyone is greatly concerned about a situation. And I've often been amazed at how quickly things can turn around. I've seen conditions where aquifer levels are dropping, and then we'll get 1 or 2 extremely wet years. We'll get a huge recharge event, and water levels will rise substantially. Problem solved, essentially, at least for a while. So I could envision the situation where we might get a really wet period, maybe 2 or 3 or 5 years, that could bring the water levels in White Bear Lake back to approximately normal levels. That's possible. I mean, I've seen, well, we're entering a period where conditions seem to be more extreme. Wetter periods are wetter, precipitation events are larger, droughts are longer or more severe. So, I mean, we could easily envision an extremely wet period bringing White Bear Lake back to its normal state. That's certainly possible.
We've got 2 questions on frac sand mining, and essentially they come down to what are the hazards to groundwater of the frac sand mining. Who wants to take a shot at that?
Well, I'll take a shot at it, and it's just a shot. Frac sand mining, there's a washing process that goes on. There are certain decoagulants that are added to the washing process. But from my understanding of it, there isn't a whole lot of other chemistry involved. So from a water chemistry side of view, that's what you're faced with in frac sand mining. The other issue then is more probably related to landscape and the changing of the landscape that goes on with frac sand mining. And in Minnesota, there's a number of different scenarios on where you can mine that sand. But in terms of water, you're changing the topography of the landscape, so there's that to consider. Those are the things that come to mind mostly for me with frac sand mining itself, not the process of actually fracking, which is a different story.
Because basically, it's a mine, and mining removes material, and sometimes mines have to be dewatered, and it's the removal of the material or the dewatering of groundwater that will have impacts. But those impacts aren't different because the sand is being mined for frac sand. So if it's a gravel mine, if it's a limestone quarry, if you dewater and that dewatering causes a problem, our methods of analysis are pretty much the same, and the permit requirements are pretty much the same. We are trying to avoid or mitigate impacts to streams, wetlands, lakes, other resources around those mines. It doesn't matter that sand is being mined for a given purpose.
And we have two questions here on that basically allude to the point that Andrew raised about the potential for tile drainage to affect recharge of groundwater. Is there anything any of you can add on that subject?
Well, the idea of tiling, again, is to remove water from the landscape as quickly as possible. So that's what it does, and it does it very well. So in a sense, you are taking water that would normally sit on top of the landscape, and you're getting it off the landscape quickly. So it does change things. It changes the way these hydrologic systems would work. If you're taking a lot of water that would normally be infiltrating and you're moving it off, then you are changing the infiltration and the recharge for that area.
You guys are all science people and not policy people, but I have a policy question here. To encourage water conservation, do you believe that increased water pricing produces good results? Are there states that have had success with this?
Yes, I know there are states that have had success with this, but in Minnesota we haven't even contemplated raising water rates really to any amount that would actually matter to people. What I heard, though, in conversation in White Bear Lake at a little cafe called Eat, was where the owner was saying to someone else that they had gotten a water meter and that now the neighbors were letting their lawns just do what lawns will do in the late summer. She was saying, well, it used to be everybody's lawns were green, and I didn't like that because I didn't want to spend my time mowing, and we let our lawn go brown, and we looked different than our neighbors. Now that everybody has water meters, everybody's lawns are brown, and I like that.
Here's a how-to question. How can a lake association test for nutrients in their lake? And it sounds like this is a situation where people went off septic systems and onto a sewer system, and they want to see if the change was beneficial, if it really did reduce nitrogen and other nutrients in the lake. Is there anything that's practical for a lake association to do on that subject?
Our agency has a program. We encourage people to monitor their own lakes with devices as simple as the Secchi disc. That's one expression of a lake's health, and you can be easily trained to use a Secchi disc. It's easy to understand its value. So that's one way that people can get involved, and they can contact our agency if they're interested.
I might comment on that. I actually saw this happen, maybe in an extreme fashion, but it was really impressive. This was Cullen Lake. It's near Brainerd, north of Brainerd. And a guy who retired on Cullen Lake had recreated on that lake his entire life. And he remembered when he was younger, the lake was a lot clearer. It was a more pleasant lake, but it had become clogged with weeds, the visibility was reduced, Secchi disk values, if they had made them earlier, were reduced. And he took it upon himself to do something about that. So he went around the shore of the lake, and in front of everybody's home, he was using this mini piezometer, this hydraulic potentiometer that I talked about, to measure hydraulic gradients. And he was collecting water from this well to look at the nutrients in the groundwater beneath the lake, basically seeing if anyone's septic system was failing. And he did find a couple of places around the lake where there were high nutrient concentrations in the groundwater beneath the lake, and he was very concerned about that. But the place with the highest concentration was right in front of his own place. So immediately he dug up his septic system and installed a new one. He was just an amazing man. And he took it upon himself to do this and got other people from the lake area, from the Lake Association, who joined him. And they basically surveilled that entire lake, over the course of the summer. So it's possible. And it was his retirement endeavor that he really loved.
Here's another Lake Association question, and it's from someone who says that the Lake Association, they're having groundwater, surface water interaction issue, and they say they have gotten different information essentially from the USGS and from private contractors, private engineers or hydrologists. Is there anything fundamentally is there any fundamental difference you would expect between a government agency and like the USGS and private contractors?
I guess there may be a difference in the type of information that was collected, maybe a difference in the procedure used to obtain the information. But I would say if the same devices and methods were used, I would expect the same outcome. Anybody else want to weigh in?
What was the assignment given? Typically, the assignment given to USGS would not be the same assignment given to a private contractor. And I could easily see that would result in a different conclusion.
I have a question for the three local experts, and I'd like each of you to just very, very shortly respond to it, please. What's the impact you see of the Legacy Amendment? How much good are we getting out of the Legacy Amendment?
Well, from our agency, it sounds like it's going to be reflected in a huge increase in the rate that we do what we do, which is make maps. And this is a good thing and a difficult thing. In some respects, in the 20 years I've been at the survey, maybe we've exchanged, a few people, a few staff have come and gone, and now we're talking about increasing our staff significantly. So that's a big change. That's a real change that's going to happen. So we're ramping up for that, and that, in my mind, is the tangible outcome of people's interest and the concern over water and groundwater. Is that there's a push now to understand what it is that is under our feet, and so that's from our perspective how things are going to change most dramatically.
Dr. Lee?
An amazing change in attitude and optimism, enthusiasm, hope that we will actually be able to get something done, acceleration of the County Geologic Atlas program, a possibility that we may actually get a groundwater level monitoring network that would compare to former Eastern Germany. They had 10,000 wells, by the way. We're going to make some real efforts toward gaining public support for water conservation. A new position is going to be hired. We got a little bit of a boost in the early days when the Legacy started up to start in on water supply planning. We have extra money for groundwater management area development. I could go on. It's great.
It's hard for me to be enthusiastic after that. I mean, I wanted to say the impact on us is huge, and Jenny said it very well. All of the groundwater, surface water interaction work that we do in our unit is funded by the legacy. The ambient observation well network that we run is run by Ambient. Contracts we have with the U.S. Geological Survey right now that I mentioned earlier on recharged aquifers, to answer that other question, that's paid for by legacy. It's been an amazing change. Instead of just doing, as I described earlier, trying to respond to the emergencies, we can actually plan to work on the real science, break ourselves free of just the day-to-day stuff, and to say, what do we need to come up with the policies that will help us control and protect the resource. So it's been enormous, and I can't think of all the things, and I'm sorry for that. But
Here's another sort of policy question, and it's not about the science, but it says, what are the policy changes that are needed to address the white bear problems?
We're supposed to write a report on that topic by January 15th. It was mandated by the last legislative session. Subscribe to our newsletter or get it when it's done.
Okay.
Well, again, this is out of my realm, but I feel compelled to say it because the stuff I've been thinking about, again, is the value of the resource. White bear is a perfect example of the first time in Minnesota, in my recollection, at this scale where you've seen different competing uses, recreational use, ecological use versus water supply for cities that are growing in this area, is that we are faced with fundamental policy questions that we really haven't had to deal with before. So I don't have answers for you, but as you're all aware, this is all based on the value of water. And so how we come up with that, it will be a difficult task, but I think that's where the policy issues will go, is to come up with an accurate value of groundwater and water, surface water.
Here's a question about describe how you would establish a groundwater management area. Does anybody want to take that one on?
the DNR is doing it, so.
I would refer that to Steve Thompson,
Sure.
my replacement and my former position. We're making those decisions now. It's obvious that public involvement is needed. There will be a way to engage the people who are impacted, the people who live in that area. We have to determine the boundaries of the area. In the White Bear Lake situation, that's going to be pretty difficult because a real groundwater boundary will not necessarily correspond to a possible boundary for management. That concept was brought home to me when I was asked, given that you could ask all users of groundwater to register their wells, even small users, so that you really knew how much water was being used, how many wells would you then have to register for a White Bear Lake groundwater management area? And so I asked our modeler to draw up the area and then use GIS to count what CWI would have. First pass like 110,000. That's not a manageable project. But now maybe you would have to take boundaries that are closer in, political boundaries. Then yes, we'll trim it down to the area that I think Perry has on some of his maps. What's the answer then, I say? 33,000? So we don't know exactly how to get started. In the Freshwater Society series of meetings we had, maybe it was 2 or 3 years ago, an outline of the process was developed by Bruce Olson from Health Department, where he just outlined how you would get started, and his focus was if water quality were one of the concerns. Now, if water quantity is one of the concerns, the outline doesn't look all that much different. Determine what the problems are, define your area, and get to work.
So I think we'll make this the last question, and I'm going to paraphrase it a little bit. The question, as it's written here, is what is being done to ensure adequate drinking water in Minnesota? But I'll just ask each of you to very briefly respond. What more needs to be done to ensure adequate drinking water in Minnesota? Bob, do you want to take a whack?
Well, this is the same point I've been trying to press and push through this evening, is that really to understand these things and to have sustainable drinking water, we need to understand what's under our feet. And again, that's self-surveying. I work for the Geological Survey. We map. That's what we need, and that is what we need, to just understand what are the extents of these units, of these sand bodies, of these bedrock units. Where are their limits? Where are there holes in them, either buried valleys or something else? So again, from my perspective, and this is again why I'm glad that the money has come to accelerate this effort, is for us to get better maps, better understanding of what's underground.
Dr. Elite, what more needs to be done?
And I will again take the public involvement side, where without change in personal behavior, we won't be able to accommodate growing population with our current water use. And if our current water use is already causing trouble in spots, maybe we're touching some limits. So we have to educate, possibly beginning with the kids, people about the danger in wasting water. Figure out a way to show people that dollars are wasted when you waste water. A realistic conservation program can keep you from having to drill another well. Not having to drill another well may not bring a cone of depression too close to a trout stream. It can all tie together, and we have to work on it from like a grassroots effort.
Andrew?
What more we can do? Jenny mentioned education, and it reminded me of a story I read in the New York Times 2 weeks ago, and it's really stuck with me. There's an area along the Colorado-Kansas border that is heavily farmed, and about 60 years ago they discovered irrigation, and yields went through the roof. And they were profiling a family, the grandson of the man who originally started the irrigation, and the wells that used to pump 1,500 gallons per minute were now pumping 300 gallons per minute. And they were losing wells all over the county. And he was putting in some new wells, and they pumped 300 gallons per minute. And he was asked, are you going to keep chasing this? And he said, well, I need the yield. I need the yield. And the author of the piece drove around town and looked at bridges that spanned nothing, and signs that pointed to lakes that hadn't been there for years. And he described it as a slow motion collision. And he ended with the thought that it would take 1,000 years for that water to recharge if they stopped using it. And all I can think of is that we have the opportunity to learn from those kind of mistakes. We're not there, but we're making decisions that are just as irresponsible as those people. And we have to recognize that, and that's what we can do.
Don, what more needs to be done to ensure adequate drinking water?
I guess I would add to what Jenny and Andrew both said. I think we need to value our water resources to a greater extent. I mean, you're right. We're essentially mining groundwater in a lot of places across the country. It will never be resupplied in our lifetime, or maybe in the next generation's lifetime. We wouldn't be doing that if we valued water to a greater extent. I don't think we'd be doing it as much. So somehow assigning a higher value to these prodigious water resources that you have in Minnesota here, and elsewhere in the country too, I think would lead to more adept management.
Well, I ask all of you to join me in thanking Don and these panelists.